Hello everyone. In this video, we are going to see very fundamental concepts of computers and programming. Let us start with what is computer. Computer is an electronic device. I have shown some commonly used electronic devices here. They are television, radio, calculator and mobile phone. All these devices have some purpose. We know what the use of these devices are. So, what is the purpose of computer? What are computers designed to do? The answer is computers are designed to perform data processing tasks. Now, the next question is what is data and what does it mean by processing of the data? Data is everywhere. We use data daily in our lives. Let us see some examples of data. What kind of data is maintained in schools and colleges? Student first and last name, date of birth, their address and phone number, and the class they are studying. Schools also have teachers' name, their educational qualification, years of experience, subject expertise, and other relevant information. Likewise, schools maintain so many other information. What data banks maintain? Name of the customer, date of birth, social security number, credit score, and other personal details. Banks also maintain total amounts withdrawn from accounts or deposited into the accounts. Not only that, if we lend some money to our friends, we note it down in a notebook. We also keep the record of all our credit card and insurance due dates in that notebook. These are some examples of data. Now, we know what is data, but what does it mean by processing the data? Assume the period where computers were not available. How the data was managed. When a new student joins, we write all the information about the student in a notebook. When a student pays fee, we store that payment information in another notebook. At the end of the month, we may have questions like how many students did not pay fee or how much fee we collected so far. We need to go through the notebooks and find answers for these questions. This is processing the data. That is, going through the data stored in the notebook to find answers is called processing the data. If you notice, we store the data as it's produced. When an event happens, like when a new student joins, someone make a payment, money is withdrawn from an account or deposited into an account. Then we process the data when we need to find answers for certain questions. If it is only few hundred students, it is relatively easy tasks to process the data manually. But if we have several thousand students, it would be a very tedious and time-consuming process. This is where computers comes into picture. Computer could store this data and process them in a few microseconds. To summarize, computer is an electronic device which is designed to do data processing tasks. We store the data as it's produced and process the data when we need to find answers. I hope this is clear. Let us move on to the next topic, hardware and software. Let us assume a robot which can understand these 4 commands. If we say walk 10, it will walk 10 feet and stop. When we instruct turn 90, it turns 90 degree. If we say take, it will take whatever object lying in front of it. The put command instructs the robot to drop whatever in its hand. Now, we have a job for the robot. There are some coconuts lying on the ground. We need to load them into a truck. The truck is standing 10 feet apart from the coconut pile. Assume the robot is near the coconut pile facing the coconuts. When we say the command take, it would lift one coconut in front of it. When we say turn 180, the robot turns to opposite direction. The walk 10 command makes the robot to walk 10 feet. Thus, now the robot is near the truck. Due to the put command, robot drops the coconut into the truck. Again, turn command. It turns back, walks 10 feet. Again take, turn, walk, put, turn, and so on till all the coconuts are loaded into the truck. Congratulations, we just wrote our first program. This is the program. Here, the robot understands list of commands, but it doesn't know what commands to execute, when to execute, or it doesn't know in what sequence the commands to be executed. It is programmer's job to decide what commands to be executed and in what order. This is called programming. Programs are otherwise called as software. If we have some other task, we just need to rearrange these commands to do the tasks. To summarize, hardware is an electronic device which is designed to understand a set of commands. Software is a group of commands arranged in a way to meet our data processing needs. Hardware is manufactured in a factory, while software is written by programmers. The robot is an imaginary one I used to explain the concept. The real hardware looks like this. We call them processor or central processing unit or CPU in short. The real processor does not walk or take. Remember, computer does data processing tasks. The real commands are like add two numbers or subtract two numbers, compare two numbers, and so on. We will see these commands deeply in the next video. Computers are designed to do data processing tasks. Our real world data is in the form of letters and numbers. For example, our names, David, John, Washington, all are made up of letters. Likewise, $10, 1 million, they are all numbers. The computer, being an electronic device, does not understand our data directly. It has its own language. In English, we have 26 letters, A to Z. Computer language consists of only two letters, 0 and 1. This is called binary language. Also, computer being an electronic device understands only electrical signals. If the signal level is 0 volt, the computer assumes the value 0. If it is 5 volt, the value is 1. We need to convert our data into binary language for computer to process it. First, let us see how the numbers are represented in binary. We use decimal system. The decimal system is a base 10 number system. In decimal system, every digit has a weight. For example, the first digit has a weight of 1. The second digit has a weight of 10. The third digit, the weight is 100. The fourth, the weight is 1000, and so on. Just multiply 10 with the previous weight. Binary number system is a base 2 number system. Like decimal, in binary, every digit has a weight. The first digit has a weight of 1. The second has a weight of 2. The third, fourth, and the fourth, 8. Just multiply 2 with the previous weight. Now, we need to convert decimal numbers into binary. For example, for decimal 3, this is the binary number. Here, the weight of the first digit is 1. The second digit is 2. When we add 2 plus 1, we get equivalent decimal number. Similarly, for this number, the weight is 1, but since it is 0, we don't have to add this weight. The second weight 2, the third one is 4th. So when we add 4 plus 2, we get equivalent decimal number 6. Likewise, for this number, add 8, 4, 2 and 1, we get equivalent decimal number 15. If we have one digit of binary digit, there are two possible combinations, 0 and 1. That means we are able to represent two decimal numbers with one digit of number. If we have two digits of binary, there are four possible combinations, 00, 01, 10, 11. That means we will be able to represent four decimal numbers, 0 to 3. If we have three digits of binary, there are 8 possible combinations 0000 to 111. That means we can represent 8 decimal numbers. That means from 0 to 7. Likewise, if we have 4 digits of binary, we can represent 16 decimal numbers. If we have 5 digits of binary, we can represent up to 32 decimal numbers. In general, if we have x digits of binary, we can represent up to 2 to the power of x decimal numbers. We have some metrics to talk about. Here, one digit of information is called bit. 8 bits are called byte. 1024 byte is 1 kilobyte. 1024 kilobyte is 1 megabyte. 1024 megabyte is called 1 gigabyte. 1024 gigabyte is 1 terabyte. When we compare decimal and binary system, decimal system is a base 10 number system, while binary is a base 2 number system. Decimal system uses the digits 0 to 9. The binary number system uses digits only 0 and 1. In decimal system, to get a digit's weight, multiply 10 with the previous digit's weight. In binary system, to get a digit's weight, multiply 2 with the previous digit's weight. Now we know how to convert the decimal numbers into binary number system. Next, we need to see how the letters are represented in the binary number system. In English, we have 26 uppercase letters, 26 lowercase letters, digits 0 to 9, and there are some symbols like plus, minus, open and close braces, etc. Likewise, there are approximately 120 letters used in the English language. Now, our problem is we need to represent all these letters in binary. To solve this problem, IEEE organization has come up with a plan. According to their plan, each letter is assigned with a unique decimal number. For example, the uppercase letter A is assigned the number 65. The lowercase letter a is assigned a number 97. Similarly, for the symbol dollar, decimal number is 36, and for the plus symbol, 43 is the number, and so on. The unique numbers are called American Standard Code for Information Interchange, or in short ASCII code. Here is the entire ASCII table. Here for each letters, the decimal numbers is given along with the binary equivalent. Likewise, there are 128 codes allocated for various letters and symbols. The ASCII code is an 1-byte code, thus it can have 256 possible values. However, for English, we only need 128 values. Thus, for English, we use only 7 bits. The 8th bit is not used. Please note that the letters 0 to 9 are different from decimal number 0 to 9. The letter 0 is a binary of 0011 0000, whereas decimal 0 has a binary of all zeros. So far, we are telling each instruction one by one to the robot. Assume the robot can read the instructions from a piece of paper. Now, we just write the instructions in the paper and give it to the robot. Robot read it and carry out the instructions. The piece of paper is nothing but a memory. That is, in memory, we can store the instructions. The CPU reads instructions from memory and carry out the instructions. Memory and CPU are the two most important components of a computer system. The real memory also an electronic component, and it looks like this. Here we can see the real CPU and the imaginary CPU that we use to explain the concept. Similarly, the real memory and the imaginary memory also given here. Let us take a look at the architecture of the memory. Memory is like a school locker system. In the school locker system, each locker can store something in it. Also, every locker is assigned a unique number. That is the address of the locker. Memory can be considered as a sequence of lockers. Here, this is a locker. This is another locker. We will call the locker as memory location or just a location. Like the school locker system, every location has a unique address. Each locker can store 1 byte of data or 8 bits. That is, every 8 bit has a unique address. Every memory location can store 8 bit of data, and every memory location has a unique address. You see lots of lines in the memory. They are wires. In this memory, there are 4 address wires and 8 data wires. Each wire transmits 1 bit of information, either 0 or 1. There are a couple of wires as well for sending read and write signal to memory. The technical term for the address and data wires are bus. Going forward, we call these 4 address wires as address bus, the 8 data wires as data bus. So, we have an 8-bit data bus and 4-bit address bus. Suppose if we want to read a byte of data from the location 0000, just place the address in the address bus and send a read signal. The memory will place the byte of data in that location in the data bus. Similarly, if you want to read a byte of data from the location 1010, just place the address in the address bus and sends the read signal. The memory will place the byte of data in the data bus. The write operation is a completely opposite one. Send the address of the location in the address bus, data in the data bus, and then sends the signal in the write line. The memory will store the byte of data in that memory location. In this way, we can store or retrieve data in or out of memory. This is how memory and CPU are connected. When you open a desktop or laptop computer, you would see a circuit board something similar to this one. This is where CPU and memory are plugged and connected to each other. Like memory, CPU also has address and data bus. The CPU also contains read and write lines as in memory. The CPU's address bus is connected to memory's address bus. The CPU's data bus is connected to memory's data bus, and the read and write signal of CPU are connected to read and write signal of memory. Suppose CPU wants to read a byte of data from memory, it places the address in the address bus and sends the read signal. The memory sends the data through the data bus that CPU consumes. Let us take our robot example. Assume the robot also understands only 0 and 1 like CPU. For each instruction, let us assign a unique number. Here, for walk instruction, the number is 1. For turn, it is 2. For take, 3. And for the put instruction, the number is 4. When we convert our first program into the number format, this is how it looks like. Just replace the commands with its number. When we further convert the program in the number format into binary, this is how it looks like. Here, this is the binary data for decimal 3. Similarly, for decimal 2, this is the binary number, and for 180°, this is the binary number. Now, we load the entire program into the memory. This is what's shown in this picture. The first byte goes to the first memory location. The second byte goes to the second memory location. The third byte goes to the third one, and so on. When we power on the CPU, it starts with address 0000. Sends the address in the address bus and send a signal in the read line. The memory returns the instruction stored in the address 0000, which is nothing but take command. The CPU carry out the instruction and then fetch the next instruction from the next memory location, that is 0001. In this case, CPU requires another byte of data to complete the instruction. It reads the degree to turn value from the next memory 0010 and then completes the turn instruction. Likewise, the CPU fetches the instructions from memory and carries out the tasks. This is how CPU and memory work together to carry out the instructions. This is a very important concept every programmer needs to understand. We will see this concept in detail in the next video, Microprocessor and Assembly Language Programming. To summarize, the CPU gets its instructions from memory. That's what we need to keep in mind. We have already covered base 10 decimal and base 2 binary number system. There is one more number system widely used in the computer world, that is hexadecimal number system. Hexadecimal number system is a base 16 number system. The base 10 number system uses the digits 0 to 9. The base 2 number system uses only 0 and 1. Likewise, the hexadecimal number system uses digits 0 to 9 and then A to F. Here, A is equivalent to decimal 10, B is 11, C is 12, D is 13, E is 14, and F is 15. Each digit in hexadecimal represents 4 bits of binary. Here, for example, the number F is equivalent to the binary 1111. The hexadecimal numbers are primarily used as a short form of binary numbers. Instead of writing such a big binary number, we can shortly write like this. When we write the binary number in a book or paper, it is easy to write it in a hexadecimal number than the binary number. That is the primary use of the hexadecimal number system. That is, it's just a human-friendly representation of binary number. Usually, hexadecimal numbers starts with 0x to indicate it's a hexadecimal number. Sometimes the hexa number ends with H as well. We have come to the end of the video. Let us summarize what we have learned so far. Computer is an electronic device designed to do data processing tasks. We know now what is data and what does it mean by processing of data. CPU is designed to understand list of commands. Programmers arrange these commands as needed to carry out data processing tasks. Computer system deals with 0 and 1. We have learned how to convert the decimal and letters into binary numbers. We learned ASCII code, which is used to represent English letters and symbols in binary format. CPU and memory are the two most important components of a computer system. We also saw how CPU and memory work together. Minimum addressable unit in memory is 1 byte. In other words, every byte in a memory has unique address. Hexadecimals are just a human-friendly notation of a binary number. Thank you for watching. Please like and subscribe my channel. Also click the bell icon to get notified when a new video is available.